So let me just remind you guys of where we are. So we're in our last life science, last 7th grade unit is ecology. So yesterday we talked about sort of an overview of what ecosystems are, how we sort of classify different parts of the ecosystem. And then we started to talk a little bit about how energy moves through an ecosystem. And one way to show that is through a food chain. The food chain just shows a direct line of one organism, which consumes another, which consumes another, and so forth. That's one way to sort of depict the energy relationships in an ecosystem. But another way to do that is through something a little bit more complex, a food web. A food web is made up of several food chains that are interconnected with each other. It's more complex. Which do you think is a more realistic depiction of what actually happens in an ecosystem? The fire web? How come?
Because it has more than just more contents, like a food chain, well, it has everything.
Okay. And most organisms don't just eat one single source of food. Many organisms, they eat several different things. And you can't show that in just a simple food chain. You need a food web to show that. So it shows that, for example, the rabbit consumes both grass and the wildflower, has multiple sources of food. So this is an example of a relatively simple food web that shows how organisms obtain energy. Remember, arrows always go from what was eaten to what ate it. The arrows are showing the flow of energy. Let me ask you about this ecosystem. If you were to imagine this ecosystem in the real world, which species do you think you would find the most of? Well, yeah, probably grass. What do you think you would find the least of? Danielle? The hawks. And this is an ecological principle. It's called an energy theory. That is this a food web or chain? Chain. Every time one organism consumes another organism, most of the energy available that's consumed doesn't go into making more of that organism. Right? When I eat this clementine, my body can't use up all of the energy it contains to make me grow larger. Lots of it gets burned up in my body just to keep me alive, to allow me to move, to keep my body temperature up. Only about 10% of energy actually makes it to the next level. And because of that, each level up the food chain you go, you end up with less and less of that organism. Here is another example. You have tiny little phytoplankton, algae in the ocean that provide the food chain. You have things that eat them. You have small fish who eat those, and bigger fish, and so forth. But each step along the way, when organisms eat other organisms, 90% of the energy is just being used up. Only about 10% makes it to the next level. And we often will show this with this pyramid shape. Okay? And at the bottom of these pyramids is always a producer. In an ecosystem, you always find that the most abundant organism are the producers. And the least abundant are the top carnivores, highest up the food chain. Which should make sense, like if you imagine hawks, right? You don't see like a flock of hawks flying around, right? You see a hawk, you see one, and it's in a very wide area. You don't see a school of sharks swimming through the ocean, right? They're relatively solitary, not that many of them. Okay? For other top predators, there just are not that many of them because it takes so much energy. There are several levels up the food chain. It takes a lot of organisms below them to support them. So these energy pyramids show the flow of energy, and each level is called a trophic level. And the size of the section of the pyramid is an indication how much energy or how much mass there is. Biomass is how much all the organisms in that group have in them. Only 10% makes it to the next level, the rest is used up. So here's another example. Imagine this ecosystem. We have grass, crickets, moles, and owls. What would you find the least of? Owls. Right. And the most of the producers. Alright. So I'm going to skip this slide. And this slide. And this. And this. And hopefully we can go back. That's a really cool video. Maybe. Alright, here we go. Now,
oh wait, I know what that is. What was inside the star?
90% of energy is lost.
Really?
Danielle.
Symbiosis.
Yeah, what is that?
Isn't it like a relationship between two different species?
Yeah, so there's when two species live in very close proximity to each other, or when they live in or on one another. And there's a few different types of symbiotic relationships that we commonly refer to in ecology. And you probably have heard of at least one of them, parasitism. What's a parasite? Okay? Sort of, but not just an invading species. Sometimes. And does what to them? Harms them in some way. So parasitism is a relationship when one of the species in the relationship benefits and the other one is harmed in some way. The one that is harmed we call the host, and the one that benefits we call the parasite. Example. What? A leech? Yeah.
That one thing that lives in a fish's mouth is their tongue.
Okay. Yeah, that's a worm. Is it a worm?
I don't know. It's weird.
Okay.
Okay.
A tick? Tapeworms? Yeah, all those things. Did I tell you guys about my dog? Tapeworms, yeah, those are parasites. They live inside of another organism. They're benefiting. Like the tapeworm is living off the food that the animal eats. But the animal that's infected with parasite is harmed in some way. Mutualism is a relationship when both of the organisms benefit from it. For example, I have a picture here somewhere. This is the Nile crocodile. It's a deadly predator. It kills humans in Africa. And it's ferocious. It's carnivore. This is an Egyptian plover bird. And this Nile crocodile opens up its mouth. This little bird walks right in there, pecks around inside of the crocodile's mouth. They have developed this mutualistic relationship in which they both benefit in some way. How does the crocodile benefit? Mitchell?
The bird's like cleaning its mouth.
Yeah, the bird is pecking little bits of food from around its teeth so that they don't decay. So it's benefiting. It's like little dental floss in there. How's the plover benefit? Maddie? Yeah, it gets a free meal of like tooth gum. But they both benefit. And so they've evolved to have this symbiotic relationship. Olympia? No, I mean, it could if it decided to, it could just jump down and swallow it, but it doesn't, because they've evolved together to have this symbiotic relationship. I'm not sure if it goes in different crocodiles. There's a lot of animals like this. Like you'll see on mammals oftentimes, like birds will go on, like sort of hitch a ride and peck around in their fur. Same sort of thing. They're eating little insects and things in their fur, but they're also sort of getting protection and getting a ride with the mammal. Yeah, it follows along the shark, cleans it off. There's lots of examples of clownfish and sea anemone. Yeah, hippopotamus, yeah.
Do you think they are to that dinosaurs had the same thing too? Because dinosaurs evolved from reptiles.
I mean, it's possible. I don't know if we can know about those kind of relationships through like fossil evidence. All right, commensalism is a relationship when one of the organisms benefits, but the other is not really affected. So an example, barnacle that attaches itself to a whale, a robin living in a tree. So the barnacle hitches a ride on the whale, attaches itself, it gets to filter a little bits of food out of the water. But the whale is not harmed by the barnacle. It's not taking anything away from it. It's just not really affected. It's not benefiting. That would be an example of commensalism. Well, that would be more of a predator-prey relationship or a scavenger relationship. So probably not quite the same thing. Nope, not leech. These are fish. These are lamprey. Lamprey are these fish. They almost act like a leech. They are jawless fish. Their mouth just looks like a suction cup, but it has rows of very sharp teeth, and its tongue has teeth on it, and it attaches to large fish in lakes and the ocean, and it basically drills a hole into the side of them, and it stays attached and digests their blood as they're bleeding. These are two lamprey attached to this trout. It's like a leech, but it's a vertebrate fish. It is effective. So this is I'm going to show you examples of several things. This is an example of parasitism. What's that? I mean, if I've seen them, so I've caught them when I was in college in a fishing boat. They're scary looking, and I mean, if you put it, my professor picked one up. He had this like rubber apron on because we were catching fish and gutting them and things, and he put the lamprey near his apron and it like suctioned right on. It was like if he had just put it on his arm, it probably would have tried to bite into him. Now, if you were just walking around in the stream and a lamprey came up, like you would immediately feel it and like freak out. So it wouldn't attach to you, but it could, I guess. Yes. So this is a goby fish and this shrimp that live together. They dig a little burrow in the sand at the bottom of the water, and they live together down there. It's kind of interesting in that the shrimp digs out the burrow that they both live in, but the shrimp is blind and it can't see. So the shrimp, when it ventures out of the little burrow, the goby fish goes with it. And the shrimp has these long antennae that it keeps in contact with the goby. So the goby's looking out for any predators because the shrimp can't see very well. And when the goby backs up, the shrimp can feel it and goes back in the burrow. And so they kind of work together. There's just a great talk about this. That's a barnacle on a sea turtle. again, it doesn't affect it, doesn't hurt it or harm it. That's commensalism.
Oh my God.
That's a polar bear with a tapeworm.
It's so skinny.
Yeah. That's because as tapeworms grow larger and larger and reproduce, they take more and more of the nutrients the animal's eating and it starts to basically starve them. There are some hermit crabs which pick up sea anemones and put them on their shells and walk around with them. It protects them because predators are gonna avoid sea anemones because they have stinging cells, and so it helps protect the hermit crab. Here's an example of what I was talking about, these birds that eat insects and so forth out of the fur of mammals. This is.
Can you please watch it?
Wait, where am I? Maybe if I finish this slide. Okay, yeah. I'll finish this slide, and I'll go back and watch a couple of these videos. So, if you imagine in your house, so at your house in your backyard, what if you or a parent stopped mowing the grass? Yeah. Okay. So let's say your parents make you mow the grass, you boycotted it. So I'm not doing it, and they're not doing it either. It's a battle of the will. Nobody's mowing the grass. So you don't. This happens for 5 years. What's your backyard look like in 5 years?
Snake breeding ground.
5 years. What do you imagine?
Grassy. Grass.
Grassy, high grass. What else? Okay. How about in 15 years?
A lot of snakes.
Snakes? Would it just be grass still?
No.
Trees.
Probably maybe some like bushes and stuff, like small little woody kind of plants might start to grow up. How about in 75 years?
Another
Some
person.
trees. How about 150 years?
Another person will buy the house and build the home.
Yeah, so in our area, because of our climate, basically an undisturbed ecosystem will go through a series of stages that we call succession. And in our area, most of our ecosystems will eventually get to a forest ecosystem. We live in an area where a deciduous forest is what's called our climax community. It's sort of what will develop if given enough time and no disturbance. What happens is one group of organisms comes in, or let's say a field. Farmer decides they're going to leave a field and not plant on it anymore. So they till the soil, it's just bare soil, and then they leave it for 100 years. What's the first things you'll probably see that year? Yeah, little small plants, grasses, things like that. We would call those things the pioneer community, the first organisms that can come in. And like you guys were imagining, it would go through phases. Smaller, the grasses would grow taller. You get a variety of maybe wildflowers. Then you might get some woody bush kind of plants. Then some small trees might start to grow. Maybe then some larger trees and then larger trees. Eventually, around here, you end up with typically a beech birch maple forest. American beech, yellow birch, and sugar maple. That's our native climax community, the ecosystem that things would develop to. If we go a little bit north of us, the climax community is different. You go up into the northern Adirondacks, or you go up higher on a mountain. What's the climax community in those ecosystems? Yeah, and more conifers, more pines and spruces and those sorts of things. If you go to the middle of the United States, right, you would find grasslands are the climax community. If you go to the southwest United States, desert is the climax community. If you go to Central America, tropical rainforest is often the climax community. So it depends on your climate. But What if you went to a forest around your house? What if a forest fire burned it down? Would it stay a charred forest forever?
No. Eventually.
Eventually it'd be back to a deciduous forest again, given enough time. So organisms can even start growing on bare rock. So that's called primary succession. If you go like up on the top of some mountains if you're hiking where there's just bare rock, what can grow on bare even before moss? There's something else, lichen, that little like scaly stuff. And as that can grow on bare rock. But as it grows and then dies, what starts to happen? It starts to build up like a very tiny layer of soil. And maybe some moss can start to grow. And after that starts to sort of die off, the soil becomes a little bit thicker. And maybe some small grasses can grow. So the soil can build up over time, even from bare rock. Well, not necessarily. That's often because of uplift from geology and things like that. So the climax is the stable community. That will be reached. Here's an example, of the stages of succession. Even ponds can go through the same. If a person has a pond on their property, just like a dugout pond, eventually it can get filled in with sediment until it's a land ecosystem. Like if you had a pond on your property, every, 5 or 10 years, you might bring in a tool to pump the sediment out so it stays a pond. It doesn't just fill up with sediment. All right. So I'm going to show you the Yellowstone one.